So let's tinker around with the Pinball Games starter kit, and specifically we'll just kind of get you guys oriented with the kit and play around with creating a main ball to roll around a table, right? So right now the kit version is just 0.9. I'm going to bump it up to 1 as soon as I'm done with these documentation videos. But if you're a CartoonSmart subscriber and you did get the early release version, what you might want to do is just duplicate this. So just take this entire folder, duplicate it, rename it something else, and that way you can kind of mess around inside of here, make whatever changes you want, and then you've got a pristine copy to go back to. And of course you can always download the latest version of the kit from the site anyway. So open up the Xcode project, and when it's first open you'll probably end up at the general settings tab, and you can see that we've got our main project settings and then our settings for specific targets, and that covers the Apple TV apps and the universal iOS app. So this would be for both your iPhone and your iPad. The place inside of here to find most things is going to actually be inside of the Pinball TV folder over here. And this is actually not really a folder, it's just kind of an abstract grouping. And inside of here is your tables.plist, which really kind of controls all the data being fed into these classes, which is essentially its own little game engine. But this is a shared file for both TV and iOS, and anytime you import in an asset to the game assets folder over here, that's also going to be shared between iOS and tvOS. And you can see over here the Pinball iOS folder really doesn't have too much inside of it. Both tvOS and iOS have their own assets.xc assets folder, which is just an asset catalog, and this is just going to be used for importing in things like your app icons and your launch image, dashboard, stuff like that. So you can see there's two folders of the exact same name, and these are device dependent, so anything you add inside of here is not going to be shared among the other device. But generally speaking, things that you put in here into the project navigator, you drag them into, from your desktop, things like that, should always be included in for both targets, iOS and tvOS. And anything you put inside of the game assets folder is automatically included for both of them. So you can see a lot of the assets that are already included inside of here, and these are being used with the existing scenes that we already have in here. So you've got a table 1 with pad.sks at the end of it, table 1 tv.sks, and table 1 phone.sks. And as you can imagine, these are the scene files for specific devices. And if I just click on one of them, scroll out a little bit, you can see the demo table that is already laid out for you. What I want to do though is create a new SKS file or new scene file and have you guys kind of start from scratch. Even if you're just using some of the same assets that are already included inside of here in the game assets folder, you'll get a sense for laying out the table and then importing in your own artwork and making your own table, because these starter kits are not about reskinning what is currently in here, okay? I don't want to see this app in the App Store with just some simple changes to it, okay? I'd like to see you guys create your own ramps, create your own artwork, you know, get a feel for actually making a pinball game. So let's do this. Let's go ahead and copy or just duplicate the table1 phone.sks file, and I'm going to go over here to duplicate. And when you do this, this is one of those rare times actually where you don't need to target this for both devices. So since we're going to do this for the phone, what you'd want to do is click over here and be sure that this particular file that we're making is only going to be included in for Pinball iOS. It's not the worst thing in the world if you, check this off and include it for TV. You just don't need to. So let's just call this demo table. And we're going to leave in here the kind of name postfix of phone, because that actually has some meaning in terms of the code, because what it's going to do is if we are using an iPhone, it's going to check to see if we have a file named demo table plus phone added into it. And then again, if you're on the phone, it's going to know, oh, this is the scene file I should be using for this particular device. So go ahead and just click over here on save, and you'll see that we now have a demo table phone.sks file. And let's do this. Let's just select everything that's currently inside of here and then just delete it out. So all I did is I just Command A that just selected everything. And there you go. We're now back down to a blank scene. And if you ever want to see your scene properties, just kind of click anywhere outside of here, and you'll notice over here in the attributes inspector, you get kind of your just general properties for the scene itself. The width is 1080, the height is 1920, so much larger than the actual resolution as on the phone. But as I explained in detail in the documentation, what happens here is your images that you've designed should also be at around 1080 by 1920, and then you export them out at just 72 dpi, which is 1x resolution. You put them into here, and what happens for the various iPhones is this larger size actually gets shrunk down, so scaled down to about, a size maybe about like this, if you can imagine a little square right there, which is going to be your actual point resolution of the phone. So any images that you include in here at 1x resolution are actually going to get scaled down and made more crispy on the device itself. And that makes it so that what we can do is just do kind of a mass selection of images and copy them back and forth between our iPad and TV, and we don't have to worry about redesigning the table each time we want to do that. So let's put a ball on this table, but to do that, we need to be able to test using this demo table phone.sks. So go over here to your tables property list file, and what we're gonna do is just copy this. So you can just select it, copy, paste it out, and you can see I've made an entire new dictionary just for this table. Let's call it demo table. All right, so it's got the same base extension name over here, and then what we're gonna do is copy that, go over here to launch with table. So when we launch the app, it's actually going to launch with the table as long as we take that part off of it, and then you can just go ahead and put in launch with menu off over there, and then paste in demo table. All right, so got those together, right? So the kit is going to load in the data from demo table. But here's the important last step to changing tables, is you want to unfold the table settings, and for SKS base name, now that's the base name of it, you want to change this from table 1 to demo table. So you're going to do exactly that anytime you want to try out a new table, right? And again, this is the base name, so you don't have to put in here demo table phone. Definitely do not do that, all right? Because what the kit is going to do is it's going to check to see if a file exists with that phone extension over here. If it's on the iPhone or if it's on the iPad, it's going to look for demo table iPad, or demo table pad. I didn't put in the I in front of these. So if we did try to launch this on the iPad right now, it's going to have trouble finding this scene file because it just simply does not exist, right? Okay, so fold that back up, and what we should be able to do now is run this on your iPhone. I hate running anything to do a sprite kit in the simulator because it is not a true simulation of the physics. The frame rate is horrible, but I can screen capture it easily here, and for this simple of a test, which should show up as just a blank screen, mission accomplished. So let's get the simulator open, and to be honest, I can't even tell right now if this actually is running, because we should just be seeing a black screen, all right? And actually I can hear some of the sounds I included, so I believe it is running, but again, we wiped out everything inside the scene, so there it is. Now what we want to do is go back over here to our scene file and actually, demo table file, and actually put in something to test, which will be the ball. Okay, so take a color sprite out of, this is the object library, just drag it in, okay, and if you're not seeing that, you probably have that toggled away, so just press right there and you should see everything you need to. And we just have an empty color sprite right here. So important first steps. Go over here and name this main ball. All right, if you've done that, next step, go over here to custom class, put in ball. All right, you're gonna do that for almost everything that you put onto the table that it's gonna have some sort of interaction with the ball, whether it plays a sound, adds to a goal, does whatever. You're going to need to put in here a custom class. Now for our ball, that's going to be a custom class of ball. All right. For other things, it might be table objects or table object. It might be light. And actually, there's not that many more. Well, plunger, flipper. Yeah, I guess there's a few. But in this case, it's just going to be a custom class of balls. So the kit kind of knows, oh, this is of the ball type, right? And then we can come back over here and do your kind of normal things like texture it. So if you just type in B over here under texture, you'll find that it'll probably fill in ball. But there's also I believe, if I go over here to the game assets folder, a few versions of the ball that you can put in here. So let's use maybe just ball. All right, it's kind of a dark ball right there, and it doesn't look like your typical pinball, right? Looks almost like a little nubby button. This is kind of a placeholder piece of artwork, and I'll explain that in just a moment. So don't think it's going to stay that way. But let's kind of finish out setting this up. Let's go over down to the physics definition. And most things that you're going to include on the table here are going to have a physics body. So don't forget this crucial step. You can choose between a bounding rectangle, which would look like a rectangle around the shape. Let me zoom in a little bit. You can also, in this case, go with circle, right? Because that makes sense for the ball. Or you can also choose alpha mask, which is a really neat option because it, for more complex shapes, it's actually going to create a body using the non-transparent pixel data, okay? We don't need to do that because this is a ball, and I think actually you're going to get a more accurate kind of circular representation if you just go with bounding circle over here. And you can see what it does is it puts the circle kind of right around the exact frame dimensions of the image. And if you were to look at the actual source image of this ball shape, it is trimmed right up to the very edges over here. So if you had a ball image with some extra alpha space around here, then circle is probably not your best option because it's actually going to make a circle using the dimensions of the image. So, you know, lesson there, just if it's going to be for the ball, just crop your image tightly around the source image. So, all right, so we've got our ball now. And we do want to put in here that it's going to be dynamic, allows rotation, and affected by gravity. If we do try to run this, though, it's just going to drop down probably even before we can even get a glimpse of it in the simulator. So what we'd want to do is just put something in here so the ball can collide and not like escape down the bottom. And I'm just going to drag in here another color sprite. We can just leave it as red. I'm going to make it a little bit bigger. And we don't even have to give it a name. We could, but the important thing is we're going to give it a custom class of table object, which means that this is going to be something that the ball can actually collide with. It can't share the same physical space with it, just like I can't walk into my chair, right? I can't exist in that same physical space. Now, the difference between the table object and what you're eventually going to do with your lights is if I put this at a custom class of light, the ball actually can essentially roll over it, roll under it, and it can share the same physical space. Still has a physics body, but they can occupy that same area. All right, so with table object, it's just going to drop down onto this table, and it might even roll a little bit, who knows. But there is one last step here as well with our table object, is that we need to give it a physics definition. Otherwise, the ball's just going to go right through it. So go over here, set this to bounding rectangle. There is no image on here, so we can't use the alpha mask or anything like that. I guess we could use a circle, though. And now what you want to do is make sure that this is not dynamic, doesn't allow for rotation, and not affected by gravity, so that this is really just kind of a static physics object on the table. And, you know, if I had affected by gravity on here, what's going to happen? It would just fall down just like the ball, right? So now let's give this a test. Okay, and I've got it running, and you can see that the ball did just kind of drop right down. You can't see that object, okay? Code-wise, what the kit does is actually makes dummy objects like this invisible. But there it is. And if you did actually want to take a look at the physics bodies, you can do that at any time by going back over here to your property list and setting shows physics to yes. And if you were to run this again, then you'll get a little better indication that the object is there, that it's falling onto. And there we go. There's the actual circular shape of the body, and you can see that it is just kind of gently rolling off to the side until it falls down. And again, this game engine knows that if the ball goes below a certain point, it's going to start it back at its initial position again. Okay, so a couple things that are slightly unrealistic with a pinball. First off, you're not going to see this rolling occurring right here, okay? Typically, a pinball is going to be chrome. The light that is reflecting off of the pinball really doesn't care that the ball is rolling, so you're not going to ever see this kind of rolling bevel effect that's inside of here. And what we're going to do to make this more realistic is go back over here to our scene, and let me stop this from running because there's a little sound playing in the background. And we're going to take another color sprite, put it out here, and I'm going to pick on one of our other balls. We have ball 3 over here that is kind of more of a realistic chrome look for a pinball, and set that as the texture. So it's going to be ball 3. And if you want to give this a name, you can just call this chrome ball or whatever you want. We are not going to give this a custom class because this is really just going to be a piece of artwork that is used inside of the ball to help define its look. So it doesn't need to have its own physics body or anything like that. And check this out, it is pretty cool. So what we're going to do is, with the chrome ball still selected, make its parent be our main ball. Right, that, okay? Now, obviously, it's not going to be off-center from the ball, okay? So while you still have it selected, what you can do is go over here and find the X and Y position. Just set this to 0 and 0, all right? Because since this is a child now of that main ball, it's X and Y positioning at 0 puts a dead center inside of whatever its parent is. And then one final thing that you're going to want to do is, just so there's no conflict between the kind of dummy artwork inside of our main ball and our chrome ball here, just set the Z position up to 1, okay? And now what'll happen is, when do we run this again? I'll give it a sec to load up. You'll see that the ball is still rolling, but it actually has that realistic pinball effect of the light hitting, your light source is not moving around with the ball. So you can see it appears like that it's not rotating, but physics-wise, it actually is rotating. But what the code does is it essentially looks at anything that is inside of the main ball, and it gives it a reverse rotation of whatever the main ball is doing. So if it's exactly inverse of what the main ball is doing, your artwork inside of here is just going to stay perfectly still or unrotated. And if you want to have a little bit of extra fun before we end this, what turned out to be kind of a long video already, just play around with moving some of these shapes. If you are going to now select your ball, be sure what's probably going to happen is that you end up selecting the chrome artwork on top of it, and then you try to move it and it does something like this. You could probably prevent that by just lock the node inside of here, and then you can move the main ball again and kind of avoid hitting or adjusting the chrome. So, if you want to do, you could just copy and paste some of the kind of dummy table objects that we've got over here. Another quick little thing that you could play around with, copy your main ball, just move it around. Let's say, actually, let's put it right here so we'll end up rolling, hitting the main ball, and give it a name of extra ball. Okay, and since we copied this, it's going to still have that custom class of extra ball. In this case, I was about to say you could probably toggle these off, but what's happening is extra ball actually has a meaning. Okay, so if you go over here to your tables property list and you go and you unfold demo table, keep in mind we copied all of this from the main example table, you can see we've got a dictionary inside of here called extra balls, and inside of that you've got a dictionary named extra ball. That name refers to the name over here, okay, of extra ball. So what the kit is going to do is it's going to look for anything of a ball type, custom class, named extra ball, and if so, it's going to go, hey, I see you on there. Well, I'm going to give you some specific properties, and one of them is to make it so that that ball is not dynamic, which means it's not going to be included in the physics simulation. It's not going to move around, but it has another property called dynamic after contact, which means that if another ball hits it, it's going to become dynamic. But if you want, you can just kind of doubly be sure that it's not dynamic initially by just toggling off these things right here. Okay. Should work either way. So let's go ahead and just see what happens. Okay, and you can see I moved this up a little bit just for test, showing you guys so that we could have a little bit more time for the ball to roll down, and then you can see that once it hits it, it becomes dynamic. It's affected by gravity, and even though you can't really tell, it is also rotating. Another cool thing too is if you have multiple extra balls on here, they all kind of get fed in the same exact data. So you can see, and let's move one of them a little further up. You'll see that making one of them dynamic, and then if that one touches another non-dynamic ball, they all cascade and kind of make each other dynamic. And again, these all get considered, you know, multiple balls for a multi-ball mode. Boom, 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 and there they all go. And if you do include something like this, what happens is once all of the multi-balls or extra balls have gone down into the drain, then the main ball gets reset back into the plunger, and if it had gone down the drain, and that's when it's kind of counted as a new round. Okay, so extra balls don't count against the player's kind of main ball count. Okay, so that should give you enough to play around with the balls and creating your own, well, very simple ramps, let's put it that way. Okay, more in the next video.